In this unit, we've seen some funky syntax that involves a less than symbol followed by a type name followed by a greater than symbol. For example, we've seen node, and then this diamond syntax we'll see is that it's called where in between these two less than and greater than symbols, we've got some type name. And the way that we've read this is node of type string. So a node that can work with strings or a node that can work with numbers. And the question is, what is actually happening behind the scenes here? And can we learn a little bit more about this in order to understand what's going on? This is a concept that's called generic types. And the motivation for this concept is that when we work with collections of data, like a list, they are often things that we want to work with respect to that list, regardless of the collection's data type. So for example, if we write a function like we did earlier, where we wanted to test whether or not a list of strings included a specific string, we wouldn't want to have to rewrite that exact same function to test whether a list of numbers included some specific number, right? It would be great if we could write one function that could work with any type of collection, so with any type of list, right? So if we have a list of strings, we want the includes function to be able to work with those input types. But if we have a list of numbers, we would want an includes function that could also work with numbers without having to duplicate that, right? So if you had to create a new type of list and new functions for each type of functionality you wanted for that type of list, it would involve a lot of very repetitive code, which we'll see as we move through the idea of generics today. And so the big idea here is that generic types offer a solution that allow us to parameterize our types at the class or function level. And that's a pretty loaded sentence there that has a lot of terminology in it. But the idea is, if we can imagine a function the way that we were able to say, give a function some parameters so that the function can take different kinds of inputs and still work. The idea here is, what if we could parameterize a class, just like we have, so for example, we might have a node that can hold types of string, or the same node could hold types of numbers. And if we want to think about this at a concrete level, we can imagine two classes that only differ in the types of their properties, right? So here we have two different classes, node number and node string. These are not making use of generic types. And if you tried to point out, well, what are the differences between these two functions? Between these two classes. Well, the name's different, right? The name's different, and they need to be. We can't have two classes with the same name. But what's really different here is that the type of this data field is different. So one is a string and the other is a number. And then the type of the next node is also different, right? Because it needs to be pointing to the next node of the same type of class. So how can we get ourselves out of this bind? Well, what we're going to try and do is move through the steps of how we can make a class that is typed specifically to be typed generically, so that we can have a node class that works for any type we want to store in its data property. Right? So the first step that we're going to need to take is we're going to designate that a class is generic and defined generically. And the way that we're going to do that is with this diamond T syntax here, with this diamond syntax. So when we define this class named node, we're going to say that node is generic for any type T. And we're making this a generic class, right? So when this is generic for any type T, notice what we're also going to need to do is replace any other place or any other instance where we had used a node of a specific type name, right? So here we're saying the next node is also going to be node of type T, right? The T here is just a name we're putting on a generic type. We're saying any type can be substituted here. This could be number, this could be string. But what we are going to learn is important is that if we go to use this class and we do substitute number here, well, inside of the body, then we would think of anywhere we used T, it also being substituted. But we could have chosen a different letter, such as U, or even a full word like the word type here. This is effectively a variable name, but by convention, in not only this programming language, but many others, such as Java, it's just common to use a capital letter T to say generically any type can be used here. We need to also update our properties that should be generically typed. So the type of data we wanted to store in this generic node class would be of type T, right? And so that's to say if we have a node of type string, then string is what would substitute T. And when we went to use a node of type string, that would mean that the data type wasn't T, it would be string. And the data type of next wouldn't be node of type T generically, it would be node of type string concretely, right? And so we can make properties generic as well. And that's one of the primary reasons we would use a generic class in order to make some of its properties generic. And so now notice that we don't have any specific types in here. This is a fully generic class. As I mentioned, once we actually define this class, we can use concrete types such as node and then number, which would mean that T is going to be number. The data properties type would also be number, same with string. And the big idea is that once we define this class generically, now we can use nodes of any specific type that we want. And we don't have to go redefine an extra class in order to do so. One little caveat here that I want to encourage you to think about and respond to on Gradescope is, in this example, notice that next could be assigned null, right? But data isn't assigned a default property of any value. Why is that? And why, in this case, could we not assign any value other than null here? Okay, so think about that for a moment and respond on Gradescope. So let's actually go try and explore this in code. And we've got an example set up today. That's the example number 2. So I'm going to switch over to VS Code and have my browser open as well. And I'm opening the O2 generic class app. And so notice that we've got two classes, node string and node number. These are just like the ones we saw before. These are not generically typed. And we're making use of those two classes up here in the main function. All right. We would like to define a generic node class. So we're going to define a class whose name is node. And we're going to make this class be generic for any type T using the diamond syntax following the class name, right? So you define a class name followed by some diamond syntax, and in that type diamond syntax, we're placing the name of our generic type parameter. And so if we want to have a data property, we can make it of type T generically, right? And so we'll make use of this in just a moment. And if we have a next property, we want the next node, because this is going to be a linked list of nodes, to be node T generically and initially null, right? So once we've defined this generic class node for any type T, we don't need these redundant node string and node number classes. In fact, I'm going to go ahead and delete mine, right? Now, when I've deleted mine, notice it created some errors up above. We've got some errors. The black screen of death is telling us we need to fix some things, right? So we got rid of the class name node string, but what we have now is node that is generic for any type, and we're going to use specifically here a node of type string, right? And so now notice that once we've done that, we're saying let A be, its type is going to be the node class for the concrete type string, right? So this is no longer anything that's generic or flexible. We're saying specifically A is going to be a node where T is string. So that means its data property is also going to be a string. And we can convince ourselves of that. If you hover over a.data, you would see that its type is string. And we can assign a string to it without any problems. And we can assign a new instance of the node class, specifically where T is string, right? So with B, we would do the same thing. We would say that B is a node of type number. And notice that that causes those errors to go away. And now we can assign to B's data property field a value of 110, which is a number. So notice that when you hover over b.data, its type is number. If we tried to say b.data is assigned hello world, we would get a type error because hello world, which is a string, is not assignable to type number, right? And so what's important to recognize here is that we defined a single class, but we defined it to be generic for any type T, such that its properties types would be based on what type we said our value is going to be more concretely. So again, to be a little bit repetitive here, when we have A, whose type is node of type string, its data property is going to be a string, right? Because T was string, so data would be a string, and its next property would be node of type string. And we could convince ourselves of that by saying a.next, and notice that it's telling us that this needs to be a node of type string or null if it's the tail of a list. And b.next, if we were to look at its type, notice it's saying b.next must be a node of type number, because we made b a node whose concrete type was number. We've already explored this in the example, but when we go to construct objects of generic types, we're actually going to need to use concrete types. So when we go to actually use objects of some class that was defined generically, we have to decide at that point what the concrete types would be. So in this case, we use string for A and a node type number for B. Right? And the idea is, once we do this, again, that T that was generic before is going to be filled in concretely. There's one more note in the slide that I think would be important to try out in our code as well, that when we have a concrete type of node string for a.next, we can't assign B there, right? So let's go try that out really quickly. We can't say a.next is assigned B. Why not? Well, if we look at the error, it tells us node number, which is B's type, is not assignable to node string, right? So these two concrete types are no longer compatible with one another, because one is specifically a node that can hold data of type number and the other node of type string, right?